All right, so I appreciate you guys coming up and looking at this. Basically, we're going to talk about SOLIDWORKS Assemblies. My name is Ryan Cole. I'm actually with Decisive Solutions. I'm one of the application engineers for those who haven't recently taken a class of mine. So one of the things that they asked a broad spectrum. They were like, do you want to do this, this, or this? And I'm like, assemblies. Assemblies are one of those things that I've kind of been working on for years now, and it's one of the things that, coming from the real world, you deal with large assemblies and how to deal with them. You're always trying to become faster at it. Sometimes you find that putting the parts together becomes a little bit repetitive and stuff like that. So I wanted to kind of give you guys some tips and tricks, and then talk about some different kinds of methodologies that maybe you could take a look at your own place of work and stuff like that. So that's kind of where we're coming from on this one. So we got the SOLIDWORKS Assemblies. The winding path of discovery here. So I'm going to talk a little bit about the 2016 improvements that we have in there. We'll also talk about large assemblies in particular. Some of the stuff that we talk about with large assemblies is kind of a broad spectrum as well too. It could work with medium size or large size or super large and even small. But what we'll do is we'll talk a little bit about the time depth that goes into it, the amount of work that you put into it before the amount of effort that you get out of it is what we'll kind of get into. And then I got a couple of miscellaneous stuff at the end, just some kind of high-level stuff to talk about and kind of look into and see how it's working there. So main thing here, updated functionality. This is one of those things that I have to capture myself on all the time. SOLIDWORKS comes out with a lot of new tools, and this year we have the breadcrumb and we got the D key, and a couple years ago we ended up getting the S key, and we had the mouse gestures and stuff like that. And what I find is, especially with longer term users, you kind of run into the that's not the way I do it, so I'm not going to look at that tool. And what I have to do is I have to break my habit of doing that. One, I have to represent the software a little bit nicer. I have to show you guys how to become more efficient. And a lot of time these tools are really focused around efficiency as well too. So we're going to talk a little bit about some of the new stuff. At first it doesn't seem right, but the more you use it, the more... Actually, here's how it works down. When I first saw it, I laughed at it, I sneered at it, and then I'm like, all right, let's give it a try. I tried it for a couple minutes, and now I can't stop using it. It's so nice to have it now. So some of the things we'll talk about here with new functionality is the breadcrumbs. Show of hands, how many guys are aware of what a breadcrumb is? We got one person. Okay, so we'll talk about those breadcrumbs. Just to kind of give the rest of you guys, they're not actual breadcrumbs, and they don't lead to your house unless it's modeled up in SOLIDWORKS. So the other one we have is the mating on the fly. Don't do this in public, you'll get some stares, so just be careful. This goes along with my warning to teaching people how to do assemblies. If you have mating issues and you call tech support, don't start the conversation out with, I have mating issues. We'll have to chuckle at you and then hang up. The other one is the component preview window. This is kind of a new functionality, especially with some of the models that I'll show you. I have to do a lot of right-clicking and select other, and this tool is just fantastic to be able to, rotate a part around and be able to get to places that you don't normally get to. So, and then the last one we have is there's an update with the copying mates with copying components inside of an assembly. So kind of get into this a little bit here. Let's look at, I got a folder here. Let's look at the breadcrumbs here. And this is pretty straightforward here, but this is one of those things that you sometimes run into. You're working on an assembly, you've got sub-assemblies inside of assemblies and subs within subs, you got parts within those subs, there's this whole hierarchy of stuff, and really what happens is you might end up having to burrow down, way down, just to get to a particular feature. Well, if it's a small feature manager, sometimes it's not too awful bad. But one of the things that I might have to get into, and let's go ahead and get in here. So I'll come in and get rid of these items here. I'm just going to hide them out for myself real quick. If I can figure out what the hide button is, there it is. And then, what it comes down to is maybe there's a particular feature that I need to get to. Now, I could right-click and edit it, but now I'm in edit part mode, and things slow down because my graphics change. But ultimately, what I want to do is I want to do something with this particular component, maybe even that particular feature. When you select on something, even in a part level, the assembly level, what you get is up here in the left-hand corner, you get what's called the breadcrumbs. The breadcrumbs are actually really, really nice because basically I can get to the sketch of that feature right here. I can get to the actual feature itself. I can even get to the part, the sub-assembly that it's in, or maybe just the sub at the top level there. So I could come over here, right-click on that, and then say open, and basically I'm able to open that sub-assembly right from that breadcrumb. I don't have to go digging through the feature manager. I don't have to right-click and look at the funny buttons at the top. It's just right there. Now, one of the newer improvements as well, too, that we got in 2016 is the D key. And I thought it was a little awkward, and quite frankly, as a longtime user, it's a little lazy, all right? So, but that's the whole thing about being lazy, is when you're lazy, you're more efficient as well, too. So one of the things that you can do is, sometimes I'm a little bit too lazy. I don't want to move my mouse all the way over here, right? So what I can do is, with my mouse still where I selected it, I hit the D key, and it actually brings that breadcrumb right next to my mouse. And that works with confirmation corners, OK, cancel, any dialogue. Hit the D key, brings it right to your mouse at that point. So it's a really, really great tool. And what it is you now start to focus right here on the graphic screen, as opposed to moving left, moving right, moving up, moving down. Everything's right there by your mouse. So start to get used to this kind of stuff. Play with it a little bit. And believe me, it's one of those things that at first I thought, this thing was a little crummy, and I'm like, really? This whole thing right here, I don't know about it. But once I started using it, I was really impressed with how much it was like, wow, I don't have to move my mouse, 3 inches. I just keep my mouse right there. 3 inches, well, I won't say that. That's awkward. All right, so mating on the fly. This is actually some of the newer things. Now, we've kind of had this capability. I think SOLIDWORKS stepped it up and didn't tell us. And there's another thing that I'll talk about that SOLIDWORKS stepped up and didn't tell us either. So, mating on the fly. Hey, look, it's Legos. So I've got a couple of pieces and parts here, and I need to mate them up. Now, traditionally we go up to the mate tool. We can click the cylinders. We say OK. And we do get the kind of nice previews now. So I can come in and grab it. It all works out good. Also, new to 2016, you've got that transparency. The first part you select turns transparent. That's kind of nice, especially when that part's on top of something else that you're going to mate it to. So it works out pretty good. But we're kind of used to this. We go into the mate tool, we pick a couple things, we hit enter, we hit OK, maybe even put a hotkey on your mouse or something if you got a couple extra buttons. Now, I'm going to go ahead and just cancel out this. It's going to reset everything back to where it was previously. And some of the stuff that we have available now is the fact that I can just pick the two faces. Now, a couple years ago, we also got the ability to come over here and click. And this is one of those tools that I've seen it and I've looked at it for a while, but I've never wanted to use it. It was one of those things that I was like, whatever. I got to look at the buttons. I'm not real sure about it. But ultimately, if you use SOLIDWORKS for a little bit, especially when you're mating stuff together, you realize that concentricities are automatic. You realize that coincidence are automatic. You realize that tangencies are automatic. Well, that's all the ones that are being shown right here as well, too. So it's like, hey, look at that. Now, I can see here that this button is actually pre-selected for me, and I could click it. So it means I don't have to try to figure out what the hieroglyphic is. I could go, oh, that one's the one that's kind of shaded, so I'll click it. But here's the next step that I found out. What I can do is I can come in, select the two cylinders, and then just simply hit the enter key. And if you do it quick enough, it just happens automatically. So I can come back in, we'll grab these two cylinders, hit the enter key, and then, you know what, dang it, I got to get in here. I got to get to the bottom of that. So the issue that I run into is I want to pick this face and I want to pick the other face. But once again, we talk about laziness versus efficiency. It is very inefficient to rotate this around, hold down control, and pick it, because if I hold control down, then I pan, so now I got to remember. There's too much stuff that I have to juggle back and forth with key hits. So one of the new tools that we have available is the ability to pick on the part, and right here you're going to see the component preview window. This is new to 2016 as well, and at first when I saw it, I'm like, damn, that just seems kind of weird. Who would ever want to use that? Here's a perfect application of it. I pick on it. The part gets opened up side by side. I can rotate this around differently from the assembly over here, so I don't have to deal with it. And the same thing works here. I pick that face, I hold down control, and then I simply hit enter, and that's going to make it coincident at that time. So when you're all done with it, you can exit the preview, and it gets out of it pretty quick and easy at that point. So once again, it was one of those tools when it came out. I was a little leery of it. It looked kind of weird. Wasn't sure I could use it. I use it all the time now. It's just a great tool to deal with. Now we talked about these as well too. So you've got these mates here. And if I come through and actually hold down the control key and pick 4 faces, last year they said if I went to the mate tool, I could go to the mate tool after selecting 4 separate faces, and it would do the with mate. It would actually center everything up for me, which I thought was kind of cool here. So the other nice thing that they did in 2016 was they actually gave us the big ability to do the with mate here. So once again, once you pick the 4 faces and you're sufficient with it, you hit enter again, with mate goes in. I don't have to get in and out of a command. It just happens. So when you get comfortable with doing assemblies and you get used to putting these mates together, it's really easy just to sit there. In fact, one of the things that I'm going to be doing here next time is I've got an extra button on my mouse. I'm going to make it the enter key, and then I can just go through, go click, 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 and all of my parts will just mate together. Never go into a mate tool, never have to go into anything else. Now, this only works for a certain amount of mates. These are your basic standard mates that it works for, except for the width one is one of the new ones. I think it works with the cam mate as well too, but we're all making cams today, go figure. So it does work with only a couple of the mates. Your more advanced ones, say your limit mate for distance or your limit mate for angles and stuff like that, you'll still have to go into the mate tool. But for 95% of all the mates that you ever do, those are going to work out perfect for you at that time. Yes, Andrew? Was I supposed to? Yeah, I'm recording. Are you presenting today? I'll be interrupting. No, thanks though. I was all freaking out about it. So yeah, I am recording. Check 1 2. All right. So we got the component preview. We got the mating on the fly, which once again, it's one of those things that when you first get into it, it seems awkward only because you might be into a habit in SOLIDWORKS. And I can raise my hand. After 20 years, I got a lot of habits that I do, but we got a lot of tools that I can break a lot of those habits. And that's what I'm trying to do. I'm trying to make myself better, and I ask you guys as users, always try to do that as well too. So keep that in mind. The last one we have here is the copy mated components. Once again, this is something that's brand new in 2016. I really, really, really enjoy this one. So let me close this down, and we'll get into here, copying components. And so basically what we have here, we got a couple Legos put together. I can see that I've got some mates in here. It's just a concentricity and a coincident on the end. I have a little bit of motion. The thing is I need another one of these over here. And if I take a look at it, it's actually 2 separate components there. It's not some sub-assembly that I have. It's one of those things that, and we do this all the time. Like we put a group of parts together. It's not really a sub-assembly, but I need like 4 of them. One of the things that you can do now is we always have the ability to hold down Control, click and drag a part, and then I could click and drag this, but what's my next steps that I have to go through? I got to remate them together, right? Well, I've got those new fancy mate tools, so it should be a little bit easier, but we can even become easier than that as well too. So I'm going to go ahead and delete those, get rid of them. What I can do here is I can actually pick the 2 components. You can do it from the screen, but I'm going to show you something that's a little awkward here. I'm going to hold down Control, I'm going to grab the components and move it. Now, how many parts do you see there? See 1 part, right? But as soon as we let it go, we'll see that the other part snaps into place. And if I just fix this real quick, just so it doesn't move around on me, you'll see that the mates actually got transferred as well too. Previously, if you're in anything other than 2016, probably the easiest way to do this is you take the parts, you make them a virtual subassembly, you copy the virtual subassembly, you right-click dissolve the virtual sub. There was a lot of steps, but you know what? That was the easiest way to do something like this. So they made it that much easier, and it's not just 2 parts, it could be as many parts as you need to at that time. Is there a question?
Actually, previous versions you could right-click and copy.
You could do the copy with mates. Yeah, the copy with mates would work as well too. So it is another function that you could get into as well. So yeah, most definitely. We had something like that. I'm not going into a command. Yeah, and even that copy with mates, there was still like 2 or 3 windows you had to go through. You had to pick the parts, pick the mates, click, click, click. This was pick the parts, right click, drag, done. Or left click, drag. So I like it. It works out really good. You can pick it from the screen, and what usually throws me is when I use the Control, I don't see all the parts. I kind of freak out. I let go of the Control, but I'll see now it won't work today, so go figure. Thanks, SOLIDWORKS. Let's see if we can do that. No. So I've got it to do it once, and I'm not sure how I got it to do it. Another question?
Just another statement. You can also do that across assemblies.
Yes. Yep.
If you've got another assembly open, I just tie them side by side. You can grab those parts.
Most definitely. Absolutely. You can take it from one assembly to another assembly. So that's actually another good point that I can bring up in the future and take credit for it. So that'll work out good. Thank you. Apparently so. Oh, yeah. There's preview window. Good. Yay. Let's fix that. Yep. So yeah, that definitely does work. All right. Good then. Good note. So Control V, Control C, or Control C and Control V. All right. All right. Large assemblies. Cue the Star Wars theme. If you guys have ever taken any of my classes, I'm pretty proud of some of my sub-assemblies that I have here and stuff like that. And if you sound that out in your head to the theme of Star Wars, it actually is Star Wars there. So Large assemblies. Really, this is a methodology. It's something that I've been kind of playing with. I've been trying to talk to people about it. I've had a couple people try it. They weren't real keen on it, but once again, the reason they weren't keen about it was because it wasn't something that they were used to, and they said some stuff that we got in there. But really what it comes down to is if you don't want to do it my way, then it's all wrong. And that's really what I run into a lot. Well, that's not the way we do assemblies. Okay, but you called me because you're having issues, so I was trying to come up with another solution. So if the status quo is okay that you have long, large lead times, or you have long load times, or you've got the really jaggedy rotation and stuff like that, continue doing what you're doing. If you are doing large assemblies and you're looking at a different way maybe to make them a little bit faster, then we can definitely go down that. So we'll go into some of the other items that we have up here, but really what I want to talk about is my Millennium Falcon. So we'll see a little bit shot of it here, and I'm just going to double click on it and load it. And really what it comes down to is I've got about 5,600 components in this assembly, and I'm running about 17,000 mates. And so what I'm going to do is I'm going to open this. I'm not going to use lightweight. I'm not going to use the large assembly mode. I'm not going to use anything like that. I'm actually just opening it natural. On top of that, I'm also running with the fancy graphics as well too. One of the things that if you look on the blogs and forums and stuff, they're like, oh, turn off your fancy graphics. I've actually seen my computer personally act a little worse if I turn off my fancy graphics. So as we're talking about this, we'll see that my feature manager is showing up right now, and we're going to see the background go from gray to a little bit of an orangish or pinkish color, and about that time is when it's going to be loaded. So earlier test today was at 44 seconds, so hopefully I can continue talking until it's done. But we'll take a look at what's going on here. So to bring it in light, it's fully loaded now. If I take a look at any of my folders here, you can see that the parts are loaded full weight. There's no lightweight parts being loaded up in here. So like I said, in review, 5,600 parts, 17,000 assemblies. I just got the assembly to open up in about 44 seconds. I have a solid state drive. When I had a spinning drive 2 years ago in 2014, this was at about 1 minute and 15 seconds to open up. So it's not that it increased it. It did increase my speed, but it's not that it increased it tenfold or anything like that. So one of the things that we're taking a look at here is, I do have the ability to rotate it around. If I look into it, you can see the reflection. There's the kitchen reflected in there. Actually, it looks a little bit better here. You'll see that as I rotate, I'm not getting a lot of that tessellation that we sometimes get with large assemblies. So it means I'm running pretty efficient here as well too. And you can see that it's pretty live time as I rotate that around. I'm not getting a lot of hiccups, a lot of stuttering or anything like that. So any ideas on what I might have done here? I'll take it to the crowd. Say it again. That's as low as you get? Fixed components, right. And that's what I had in there. So one of the things that I found out, and this was actually a long line. If you saw the little slideshow that was going, you see that I've been working with the Legos. I've been playing with Legos and SOLIDWORKS since probably 2003 timeframe. And what had happened is Lego brought out this particular model. It was running about $4.99. I was like, wow, that's kind of nice. And I talked to the wife, and she's like, yeah, it's not that nice. So I couldn't get it. So they made 20,000 kits basically and quit making them because no one's buying $500 worth of Legos except geeks, and apparently my wife's not a geek. So really what it came down to is I finally got to a point where I'm like, you know what? I'm going to try to make this in SOLIDWORKS. So I'd started small with a little 300 model, then went to like a 350 model. One of the ones that if you saw up there, I had a Lego statue of Yoda. That was about 1,400 pieces. So what I did was I progressively got bigger and bigger. And probably about a year after I came into this company, I realized that, one of the questions that I get from you guys as a tech support representative, as a trainer, is I had a lot of complaints about large assembly performance. Like, why is it so slow? It takes so long to open up. It's just horrible to work with. And so what I then realized is that I could now play with Legos at work, because what I started doing was make bigger and bigger assemblies and then eventually get to the point where now I can start seeing the issues that you guys were running into. So what I found out is that it's not so much a piece part count that you really run into. Really it comes into the mate count. And on this particular computer, when I get to the about 3,000 to 4,000 mate range, I see my computer take a huge dump. Now, 3,000 to 4,000 pieces is only that's only like a couple hundred pieces, really, if you're looking at it. So everything is mated fully in here. I didn't use that fixed constraint that we have, that fixed so it doesn't rotate or stop rotation mate. So I literally showed you how I put the parts together earlier. That's the same methodology I used here as well too. So everything's mated together. And then as I was going through, I realized that I'm like, oh, you know what? If I fix a component, the mates for that component get locked out. And I'm like, okay, so that's kind of cool. So basically what it comes down to is I started thinking about methodologies in the past we'd run across. I kind of consider myself a little bit of a purist in SOLIDWORKS. I was the guy that will have thousands of mates to put a part together and just deal with the long load times and just deal with the fact that it could blow up or whatever. The huge benefits that I got there, and actually let's take a look at the PowerPoint. So some of the pros that you have here by fixing it, well, I'm sorry, take it back one more step. So you kind of had two people on the line. You had people that would put parts together, blow the mates away, and then fix it in space. And then you had another group of people that would put the parts together with mates, leave them there, but then complain about long load times. That's really what we had there. I was kind of one of those guys that said, I want all my mates there, because if I do a change to a part and I go back into my assembly, I had automatic updates. If the other guy made a change to his part, he had to go back, and then he had to remate parts together, and then he had to delete the mates, and then fix it back in space. That just seemed real weird to me. So as I was looking at it, I kind of realized, I'm like, well, hey, with this fixed relationship, I'm suppressing the mates. So, yeah, there's the mates are still in the assembly, but they're not part of the calculations anymore. So now my rebuild times are going to speed up and stuff like that. So basically, if you go through and fix it, and if I take a look at my assembly here, and I go look at my mates here, now I am using sub-assemblies as well too, which is always a good thing when you're dealing with large assemblies. But you can see that all of these have an F next to them. If you suppress a mate directly, it'll just gray out. But if it gets suppressed because a part is being fixed, it's going to gray out just like it does, but it's also going to have a little F next to it. So you'll see that a lot of these have Fs next to them. Now, as we go through, you'll see that some of them are still active. They're a little bit darker and stuff like that. A lot of times, these are parts that still need movement. Like if I look down here, I've got the little docking door that needs to move up and down. Those are mates that I would keep active at that time. I wouldn't fix that component. So as I went through here, I said, oh, this is kind of cool. And in this particular case, what I found out was this piece right here, this cap piece that's on the top, it's like one of the first things you do in the model. They're like, make two caps. One's going to go on the bottom. One's going to be the last piece you put in. So there's about 2.5 months time that I worked on this. So it's about 100 hours overall just putting the parts together in SOLIDWORKS. And I got to the very end of it, and I was sick of Legos. I was sick of Star Wars. I didn't care about the ship anymore. But I had to finish this. It was one of those things I just needed to get it finished. So I took this cap piece, and if you kind of sneak in here, there's some forks right here. There's a fork piece that you can see right here that goes between two other pieces. That's what kind of aligned it. So I'm doing the last steps. I'm putting the last mates on, and I put it in, and I do the zoom to fit, and I see that this piece right here is moved forward one little block. And I'm like, you got to be kidding me. Because that block was made on step number 25 out of 380 something. So I sat there and thought about it. I'm like, you know what? I fixed all these components. This is just going to be, I'm in the whole fixed component thing. This is never going to work out. The cool thing is if you have a component that's fixed and it has mates that are suppressed because it's fixed, when you right-click and float the part, it also unsuppresses the mates automatically for you. So now what you're doing is you're leveraging SOLIDWORKS to know how to look in this big list and unsuppress something. So basic steps here where I went to the sub-assembly that it was connected to, went to the other sub, and then I got to the part, and then I right-clicked on the part, floated the part, edited the feature, moved it one over, and then I went fix, all the way back up. Something that I thought was going to take me a good half hour to kind of get it done, it took me less than 5 minutes to actually get it done. So I thought it was actually pretty beneficial at that time. But then I started getting all the points to put together and said, oh, you know what? I'm starting to realize how you have to work in here. So if I go back to my PowerPoint here, the pros of doing this is, as you can see, super fast opening times. 44 seconds for 5,600 pieces. That's pretty nice. The only thing I can compare that to is I used to work on RV chassis. We'd have them fully loaded out. 5,600 pieces was about, 5,000 pieces was about the size of those. And we were looking at anywhere from 45 minutes to an hour. And that's even with the PDM system loading locally and everything. I mean, they were just massive files. So going from something that size, 45 minutes, down to 44 seconds, I think that's a pretty big leap there, all right? The other one is the mating information is left intact, and it isn't calculated every rebuild, so that's where you're getting your benefits. Now, some of the cons that we have here is, well, it's some of the cons about going the other way, super slow opening times, that shouldn't be there, so we won't talk about that one. The mating information is still left intact, but the problem is if you update a part, it's now on your shoulders that you have to go into the assembly. You have to float what needs to be moved. If it needs to automatically update, it'll move to the right location. You can then right-click and fix it. It might be one part, might be 20 parts. All right. So what I kind of look at it is there's always a time debt, and this is what I think about. So right now I'm able to open up something in 45 seconds that could possibly take anywhere from 45 minutes to an hour and 15 minutes to open up. I'm saving quite a bit of time. Would you guys agree? Okay, so if I have to spend an extra 10 minutes to make my assembly update correctly, that's the difference right there. So if I had all my mates in and I had to wait an hour and a half to get it open or an hour or anything like that, just so it would automatically update, that's not good time usage on my side. So I think personally, I think it's well worth it to be able to go in there. So the big downside that we do have is that if I do this assembly and give something to you guys and you have to make a move, you kind of have to know the assembly a little bit. That's the only thing that I can really see that I can't really get around. But if you kind of put your assemblies together logically, I don't think this would be too difficult for someone to go through, especially because I've numbered it. If I gave you the instructions, you could actually go to instruction number 26 and then go, oh, there's 26, here's the files. So a little bit of logic on the backside, a little bit of logic of how maybe the group of people put things together, that might actually help in the long run. So there's some good things to it, but there's some stuff that needs to kind of be settled out. And there's no functionality that I can say, man, we need this function to make this better. I think it's just one of those things that it's really a work ethic at that point. Fair enough? So I am one of those people that as I go through, I want to always look for efficiencies. I'm always looking at a time debt and everything like that. For me, the time debt's good for me. I'm saving an hour. That's going to take me 10 minutes to update things. I'm fine with that. The other thing that you run into is, as far as the time debt, is, there's a prodigious use of configurations in here as well, too. So while I'm loading a 5,600 piece assembly, if you look at it, there's only 300 unique files that are being loaded in. And then out of that, there's only like 120 actual part files being loaded in. And it's only because, in a case like this, configurations work great. In fact, if I take a look at a particular component, like this one right here, those are those flat plates that Legos has. There's probably a couple thousand of these parts alone in this assembly. I'm only loading one file for all those thousands of parts. So right there, that's a huge gain in time right off the bat. So it's not always available for you, but there's things out there that you can take a look at. So keep it in mind. It's something that I want to make sure that you understand the downsides and the upsides to it. But you never know. You might want to give it a try and just see how it works out. And I'm always looking for feedback as well, too. So if you guys happen to try to utilize this and you have some questions, my contact information should be available through the user group here and stuff like that. Shoot me an email. I'll be more than happy to get on a phone, look at a go-to, even look at a model. Andrew?
Just a really quick question. If you're in product development like Claude is, if you have one part that's used in 50 different assemblies, and it's fixed in all 50 assemblies, and you modify that one part,
Yep.
you have to go to PD and take ownership, not take down.
Absolutely.
Put it on your shoulders to update all 50.
Yep.
No way of knowing the next guy will kind of.
And technically that would, I had a lot of arguments with my own engineering department with that as well too, especially when we went to PDM. One of the things that we got into was someone had changed a part, and they came up to me and they're like, I didn't realize this, but I allotted 4 hours to change the part in the subassembly that it's in, but when I did the where used in my PDM system, we found out that it was used in 40 different places. And so now it was my fault that we went to PDM because now I made more work. So, and it's an argument that we had to have, and the only solution I could come up with is make a new part number. And they said, well, we can't do that because it's going to cost $180. That was like our bottom line to create a new part number. But when we looked at it, it was going to cost engineering like $3,000 to update all the assemblies. So at that point, you're like, I think I'll make a new part number. So it's one of those things that you got to kind of look at. And that's not just going to affect this particular methodology. That's an engineering thing all throughout. So, it's always that fit, form, and function. If we can make it still work everywhere else, then technically we don't have to go update everything else. So yeah, but good point there. Thank you, Andrew. Right click. I get about halfway through, and then I do a Control A, especially like in a sub-assembly. Like I just did something real bad here, so don't look at the screen. Just you can do a window around everything, Control A, and as soon as you have everything, just right-click on one of the parts, say Fix, and all of them fix out for you. So, and I do work. I'll work with a couple hundred parts, mating it together. But when I see my computer start to chunk a little bit, window everything, right-click Fix, and it fixes out at that point. Yeah. Yep. Yeah, absolutely. Yep. Yeah, so, and that's that. I always leave that first one fixed, so if I do a Control A and float, I'll just go right to that first part, right-click Fix, everything kind of stays standard at that point. So yeah, it's like I said, it's a little bit more thinking on our side, and if you're used to the, SOLIDWORKS being automated for you, it's kind of a little bit of a cry. You're like, man, I gotta work more now, but ultimately you're saving more time. You're working a little bit more, but you're saving a ton of time.
What if you're working with sub-assembly instead of trying to work in this?
Mm-hmm.
Like I see a toolkit or something that's a sub-assembly.
Mm-hmm.
This and that. You're always working with sub-assembly. If you change your sub-assembly, you're only in that one little area.
Yep.
And then when it comes in, it's all there.
Yeah, but if you change something in your sub-assembly that's going to cause it to shift over in your main assembly, that's when you'll have to float it and fix it real quick.
Yeah, but it's just that one sub-assembly. It's not like a whole difference. You just got different sub-assemblies.
Yeah. Well, yeah, in this case I have different sub-assemblies. So if I open up here, this is one of the subs there. This is another sub over there, and then you have the main sub at the very top. So this is actually made up of two sub-assemblies right here.
That's the point, though, is that you're working on these small areas to really quite focus.
Yeah, yep, absolutely. But I still have to go to the main level and make sure that any changes I did at the sub-level are okay at the top level as well, too. Or else there's a rework on the floor, and we don't want that, right? So I didn't know I needed to re-drill that hole. All right, last thing we have here is it's actually pretty old technology, and it's called a speed pack. So show of hands again. How many of you guys are familiar with the term speed pack? Yeah, it seems pretty small. How many of you guys are working with assemblies at all? See, a lot more hands go up there. So speed pack is one of those things that it's got a little bit of a love-hate relationship. Speed pack is actually really cool. So one of the things that I could do is if I were to open up a sub-assembly, I could get about 5 or 6 of these in the sub-assembly, bring this in as a sub-assembly. I get about 5 or 6 of them on the screen, and I see my computer start to take a little bit of a hit. It's really starting to chug. It's very noticeable. When I rotate, the whole thing tessellates out. It's just like, wow, okay. So one of the things that you have the ability to do is something called a speed pack. And if you come over here, it's actually under the configuration tab. And if I pop this out, there is a speed pack underneath here. So mine is out of date. We won't talk about that as well, too. I'm actually going to show you that. But one of the things that you do is if I click on it, and activate it, and it's going to take a second to pop it up. The speed pack, what it does is it basically dumps math data in the background. And what you do is you end up working with not a lot of extra data. So ultimately, the whole thing about the speed pack is you're going to tell SOLIDWORKS what you want to be able to touch, and then everything else goes away, except for what you want to be able to touch. I probably should have tested this out before I got in here. There we go. Come on, you could do it. So in a case like this, what I found out was I actually got tired of bringing copies into a top-level assembly when I got about the 20 range. So I had 20 Millennium Falcons sitting on the screen. I went, okay, there's obviously something better, because when I got about 4 or 5, it started slowing down here. I was still running full-time. So at this point, the speed pack has been loaded. Do you guys notice anything different? If I rotate it around, look at it, everything looks the same. What you'll notice, though, is you get this. This is called the ghosting effect. The ghosting effect basically says anything that isn't in the actual model is not going to be shown. And the reason we do this is so that you can tell what you can pick and can't pick. So here you can see that I've actually picked a couple of surfaces. These are surfaces on the bottom of the part. I've also picked a couple of parts as well, too. All these, I'm able to actually come in, pick, and actually have surfaces to mate up or anything like that. So if you've ever seen those really huge plant floor layouts and all the machines are on the floor, I'll guarantee that each and every one of those machines is a speed pack. Now the big difference that we have here is the problem that most people have is if I were to add an extra part to this, what happens is you get this little no symbol here, the little warning. And basically what it says, hey, I don't match the geometry that it was before. And it's funny because I've actually gone into companies where I think SpeedPack will work out very well for them. And I go, you need to use SpeedPack. And they go, oh, well, we used it before, and it didn't update when we updated the assembly. And I'm like, okay. And I'm like, so what's the problem with that? Well, it's just real hard to kind of get that SpeedPack updated and this and this and that. Blew my mind. The reason being is if you need to update the SpeedPack, you simply right-click on it and say Update SpeedPack. It grinds a little bit, regenerates the graphics, and it's all done. So really their problem was 2 mouse button clicks, a right click and a left click. So it is one of those things. It works out really well, but it's so weird, especially with this whole thing here going on, this whole ghosting effect here. So when we first brought it, this was the biggest deterrent right here. I don't like the ghosting effect. So we did what we always do as a bunch of users and stuff like this, and I happen to be a user at this time. We all complained about it. We went to SOLIDWORKS and said, really, we can't hack this. This is just weird, and I don't like it. And they're like, what are you talking about? And we show it to them, and they're like, oh, you don't like the ghosting effect. We're like, yeah, we don't like the ghosting effect. That's what we don't like. So we all got on board, and we all put this enhancement request. Get rid of the ghosting effect. So what SOLIDWORKS did there is they actually got rid of it. Now, if I edit the SpeedPack here, we're going to let it grind for a sec here. They actually have an option down here now that you can turn off the ghosting. And how many of you guys have done this before? Has anybody done this with SpeedPack? All right, so come on, SOLIDWORKS, you can do it. So what happens is probably about 2012 or 2013, they said, okay, we put an option in, you can turn off the SpeedPack. So we said, that's great. So we come down here and we say, remove gross graphics. And we said, okay, and we got out of it, and this is what ended up happening. Okay, the mouse thingy isn't the ghost, it's the graphics that are the ghost. So when we said get rid of it, and they tricked us. That's how SOLIDWORKS works sometimes, right? They're like, be careful what you ask for because you're not going to be happy with it. So if you ever put an enhancement request in and SOLIDWORKS contacts you and says, do you really want that? That's like the genie in the bottle. Like, really think about your answer because you might not like the response. But in the long run, this actually helps out as well, too, especially if you're working with a large floor layout. Probably the biggest assembly I've ever seen had 275,000 pieces in it. It was a floor plan layout. All the machines were on the floor. They were using SpeedPack. It was beautiful. But even then, at 275,000 pieces, you could see that it was chunking just a little bit. And then what they did was they turned off the ghosting graphics, and while they were working on it, it worked great. Very fast, very responsive. And then when they were ready to see everything together, they had a review or they had to show the customer, they just go through and turn that back on, and it looked like normal again for them. So there's a lot of cool benefits there, but once again, we're kind of looking at that time debt. How much work goes into it? How much time am I getting out of it? Is it worth my effort to put into it? Once again, I think this is one of those places where a little bit of effort put into it reaps you a lot of rewards out of it. So once again, just got to put a little bit of extra work in.
Not that I recommend it, but you can turn the circle off.
Can you?
Yeah, the settings.
Oh, is it through the settings? I'll have to look into that. So thank you.
I recommend using it personally.
Well, actually turn it off and then give it to your coworker. That could. Not that I would do that.
Little black and white circle.
Do you? Oh, okay. So it does tell you if you can't select it or not. I wouldn't tell my coworker that though. That's why I work alone at my house now. I've been shunned. All right. So SpeedPack, right-click and update. That's seriously. I mean that is literally. Outside of the whole graphics thing, that is literally the biggest complaint I get out. It doesn't update automatically. Right-click, update. Seriously, just move on from there, all right? All right, so PowerPoint doesn't have a auto-correct. I mean, it does, but you got to turn it on. That seems dumb to me. So it took me a little bit, and then I figured out MISC would work out fine. Miscellaneous. So working with large assembly drawings, I don't really have anything to show here, but how many, show of hands again, how many of you guys are working with assemblies that start to affect the speed of your computer? Okay. Would you say that's more pronounced when you get into drawings as well? Okay. So one of the things that I found out, and actually it's something that I've said for years, and then it finally dawned on me that I could say it for something else, is during our training class, especially our essentials classes, we talk about how shaded mode inside of a 3D model is actually the fastest way to show the graphics. You get a lot of people from some of the other older CAD systems like Unigraphics and CATIA, and they're used to watching things in wireframe because that's the fastest way to show them there. And quite frankly, if you've never worked in wireframe, it's great because if you're working on it and you blink, you can literally invert the geometry in your head. And when you rotate it, it looks like it's moving left, and then you get a pounding headache, and I just didn't like it. So I went back to SOLIDWORKS. So one of the things that I ran into is after telling people for years to run shaded mode, run shaded mode, run shaded mode, eventually what I found out was, wait a minute, if I'm working on a really large drawing, a really large scale drawing, man, it's just acting so slow. Well, one day on a whim, I said, well, let's turn the views into shaded. Well, you got to remember, those views that we have in a drawing is just your 3D part captured in a particular orientation. So if you're working on a really large drawing and you're noticing this really large, like big hits to your computers, go to it, take the view, turn it into shaded with edges even, and you're going to find out there's a huge increase in your speed. In fact, I went on site to somebody one time, and they were complaining. They had really large assemblies. In fact, they did large-scale doors that you would see, like big garage doors that you put in big buildings like this. And lots of little details and everything. In fact, one of the things that I found out was they had one of those little screws that they downloaded from one of those companies out there, one of those big sites that you can download. And I have to say, it was the most beautiful sheet metal screw I had ever seen. Every little fillet and chamfer and thread and writing on it. Like, I looked at him like, wow, that's awesome. And I looked at him, I go, how many got in here? I don't know, about 500 of them. And I'm like, oh, holy cow, So the first thing I did was I just hit them. Just so the graphics weren't being generated. That was night and day. Like, I was like, wow, that's like, holy, that's great, And I said, okay, well, here's something else we can do. I turned them on, it slowed down again, and then I just picked on the view, said make shaded, got all my speed back instantaneously. Because even though there was a lot more geometry, the shaded worked a lot quicker, a lot faster, a lot better. So one of the things that I'll tell you guys is that you don't want to leave it shaded. Number one, if you print it out, your IT department's going to have a canary because that's a ton of toner that comes out. Number two, I've also heard arguments that, well, that's just more memory being used. No, it's not. Actually, it's lessening your computer CPU. There's no extra memory being actually taken up. There's no more processing power or anything. In fact, we're relieving processing power. And then the last but not least is you make a 2D drawing and have it all shaded in, and then you show a customer, or maybe some of us have management that don't understand CAD, and they start scratching their head like, what's going on? So we have to turn it. So what I tell people is, it's that time debt. You're going to turn it on so that you can work on it quickly, but later on you're going to have to spend some time turning everything back to regular, hidden lines shown, hidden lines removed, or whatever. So it might take you 10, 15 minutes to go through that, but think about the time saved while you're able to work quickly in your large-scale drawing. Does that kind of make sense? All right, so are you seeing this common theme here of putting a little bit of work in to get a lot of effort out, or a little effort in to get a lot of work out of it? That's kind of what I've been going on, and everywhere I've tested this kind of hypothesis, it actually has seemed to work pretty well. So that's why this is one of the reasons I like assemblies, is because it's real easy to kind of show these paybacks very quickly. Last thing we have here, this is, how many guys are, another show of hands, how many guys are using virtual parts or virtual assemblies? Got one or two. How many guys know what it is? All right. So virtual, I've actually, when I first saw them, I thought it was kind of weird. Like, why would I have a part that doesn't exist in real life? And I actually, the first time I used it was the virtual assembly, and that's what I was talking to you guys earlier. I might have assembly that's all put together, or a bunch of pieces put together. I would pick them all, create a virtual assembly, copy the virtual assembly, dissolve all the assemblies, and that's where I was transferring a lot of my mates over and stuff like that. So in a case like this, we'll take a look at the end effect here. Oh, look, it's Star Wars again. Go figure, right? So in the case that I was looking at here was there was a couple of pieces that actually got put together, and it was a nice wobbly hose. How many guys are dealing with hoses or springs or chains or anything like that? All right. Do they animate? No. We just kind of put them in, and if something moves, we do a change or whatever and stuff like that. So one of the upsides of what I was trying to do here was, I still have a lot of movement here. And this one is a little bit less than the other one. as far as the part count is concerned, and I kept a lot of movement in here, so I can grab a part, move it back and forth. At home by myself, I make the beep beep boops and stuff like that. This item comes in and out, so it all works out pretty good. So, and just to give you guys a heads up, I don't come up with this. I go to the Lego website. You can download all the Lego instructions you want for free. I just get the Lego instructions. So it's I probably have built about $4,000 worth of Legos, and it's only costed me nothing because I get the program for free through work. So, all right. So when I take a look at it, one of the things that we have here is this part will move back and forth. And so we'll see that I can see how that bends back and forth. And so what I'll do here is once I bend it, I'm going to go ahead, come back in over here, and then just simply do a rebuild. And what will happen is you'll see that this part will rebuild itself so that it comes in at the right orientation and everything. So it's not something that's instantaneous during your move. You can't move it and see it bend and flop all over the place. But if you guys are running any kind of animations, SOLIDWORKS will move a little bit, rebuild, move a little bit, rebuild. So you can actually animate this and see a movie of it actually flexing and stuff in space. So you can see the part comes here. Now, the thing that I have here is that these are virtual components. The reason being is I don't want a part file on the outside that's wiggling around all the time. Yeah, that's just going to be something that we run into. The last place I worked at, we did the chassis for RVs and stuff like that. And where we started using this was our hoses. And we'd have a hose that would run from the front of the vehicle to the back. Now, I did Class A chassis, so we're talking anywhere from 28 feet to 45 feet long. Some of the hoses were, 60 to 70 feet long. We had return loops. We had all kinds of stuff. But the thing was the one hose was called out as one part number, but it was used on every single chassis, and it was never put in the same way. Sometimes it went under, sometimes it went above, sometimes it went through, sometimes it went in and out. And the problem that we ended up truly having there was we had a part file of this hose with like 300 different configurations. And you click through the configurations, and basically it was a bunch of suppressed items and a new sweep, and then a bunch of suppressed items and a new sweep after that. So the problem that we run into mostly was some of the newer users or some of the inexperienced users would get in there, make a change, and mess up 300 configurations. And so probably about once every 3 to 4 weeks, someone came to my desk, Ryan, the part's messed up, can you fix it? We'd go in, pull the old backup out, go into our PDM system, whatever we needed. So to get around this, what we did was we ended up making that part file just a chunk that was 12 inches long. That went on our drawing. And then after that, what we did was we created virtual components in each one of our assemblies that we used it. And so what it is the virtual assembly said it was that part, but it didn't exist outside. It never messed up my drawings. It never messed up any other install of it or anything like that. So it kind of lived where it needed to live. I'm not going to use this part in any other assembly. If I do, I'll just recreate it because it's actually easier to recreate it than it is to try to get this to work here and here and here. And on top of the fact, we're using in-context relationships as well too. So it's not going to be something that is going to be easy to put into another assembly, especially if it's wiggling around and whatnot. So what I'll do here is I'm going to just take a right click. I'm going to open it up. And ultimately what I did here is that's the end result. And if I take a look at my features here, I created a plane at the end. I did a revolve. And then before I did any of that, let's break it apart. There we go. This is what I started up with. So at the assembly level, I inserted a virtual component, and then I created this three-dimensional spline, made sure I had relationships to control the tangencies. One of the things that you can do with splines, even though it's not an assembly thing, is you can put a dimension on the spline, and no matter what you do to it, it has to stay that length. So that works out pretty good because it's a fixed length that I have to work with. If you've ever had to try to do this, probably a couple of years ago, we've had this capability for a while, but that's one of the reasons we never did this, because technically you can make something that's 12 inches long, all of a sudden it shoots out to 4 miles long because it loops around and does something goofy. This really does restrict its movement, so it works out really well there. So we've got those components together. Once I did that, I used the new functionality for sweeping. Have you guys seen that, where you can just pick a profile and you just kind of go in there? Basically, this is what it looks like. I picked the line. Oh, that's the wrong feature. There we go. So in this particular case, it's called the circular profile on the sweep now. if you have a path and you're going to put a circle on the end of it, it used to be that we'd make the path, put a plane at the end of the path, draw a circle, and then sweep the circle along. Now you just pick the path, and if it's circular in nature, you just tell it to make a circle. So I actually used this path twice. One was to make my sweep that went through, and you'll notice that it's at the end. The other one was that I used it to create the curve-driven pattern of this as well too. So basically I put a little ball at the end of it. I said don't merge, make a bunch of copies of these, and then now I have 24 of these on the screen, and then I use that sweep, and because it pierces all those little copies, it then merged everything together. So there's no extraneous features in here. So it's something that was very easy to do, and it came out pretty quickly as well too. So that was the virtual component that I ended up having in there. And then I got done with this side, and we'll let it come up here. So you'll see the two different hoses that I had to put in. And then when you get done with it, I'm lazy enough not to want to put the effort onto the other side. But you'll notice they are over there. And this is broke, so we won't look at that. I used the mirror function. So what I did was I took a virtual component and then created a mirror of it as well too. So none of these parts actually exist in real life is really what it comes down to. But if I were to run an animation with this showing the wheels going back and forth, we'd see those flexes hosing with everything, and it would look really nice. It would give it that little bit of realism. If you guys are doing machines and you've got maybe hydraulic lines hooked up to something and that you got a carriage moving back and forth, it gives it that little bit of extra realism as opposed to just looking at something static. So it is one of those things that you can take a look at. There's a lot of ways, or there's a lot of YouTube videos out there as well too for animations showing this kind of stuff. But if you've ever seen springs flex in an animation or hoses flex, this is the methodology that they're usually using there. So I'm really struggling not to do the BB boop. So there we go. Yes, sir. Yeah. Sure.
I was at a customer, and they're talking about how they manage their purchase libraries.
Okay.
So they would say we download a McMaster car cylinder, HP cylinder, whatever, and you might get 2, 3, 4, 5, 10 parts, depending on what you're doing. And then all those 10 parts purchasing lines obviously might need some animation or some movement.
Yeah.
That gets put into an assembly.
Yeah.
And they actually have PDM, so they're like, it's very difficult to manage all this data.
Right.
So in purchase commodities, when all you really care about is the top level assembly, they make all the parts virtual. You only dealt with a singular file.
Yeah.
And you just copy that one file down, and all of the cylinder bodies and
The wipers and
the clevises and the mountings and
Yep.
all that just goes with that single assembly.
Oh yeah, definitely.
That was the best use I ever heard of for
We had something very similar. We had a customer that was getting circuit boards with the components on them from one of the automotive companies, and they had a PDM system, and they had a very strict structure that says any part that went in the PDM system, you had to give it all of its characteristics, all of its data, and this data card and stuff. And they were very strict with it, but it ended up biting them a little bit in the rear end. So they called us up, and they're like, is there any way we can get around this? So what they did was, this was like a 400-piece assembly, and it would take 3 to 4 days to put it in. And then what they did was, we turned around and said, try using a virtual component. So they did exactly what you did. Brought the assembly up, right-clicked, made everything virtual, deleted all the other files. They had one file to bring in. It was like a 2-minute deal. So we went from 3 days to 2 minutes. So the PDM was a little wishy-washy with it at first, but then we ended up working through some of the issues that we had. So it was kind of nice. There's all kinds of really, really good uses for them. So it is definitely, I can't tell you the number of times I've gotten calls like that, and they're like, I'm going to use a virtual component. And they're like, oh, we tried them, we hated them. And then I show it to them, and they're like, this is great, I love this tool, So, yeah, most definitely, and that's a great way to think about it. I actually got miscellaneous figured out too, so I didn't need autocorrect, so I was all happy about that. So I just put it in again. Thank you very much for your time, guys. I appreciate it. If you have any questions, I'll be hanging around for a little bit. You'll see me walking around as well too, and hopefully it helped you out. And if you guys decide to use that methodology, let me know. I would love to see this. If you run into issues with it, I'll be more than happy to take a look at it and see if there's something we can take a look at. I mean, I'll be the first to raise my hand if it's something that I didn't think about and go, oh man, I didn't think about this. but that's also going to make me go back and sharpen my pencil as well too. Fair enough? All right. Thanks for your time, guys. Appreciate it.